Hello everyone, welcome back to Chemistry CC for you. So we are talking about the CUET entrance examination for the UG 2023. So as you know, our channel name is Chemistry CC for you. So we'll be focusing on all the aspects, and specifically in the domain part, we'll be focusing on the chemistry part of the preparation. So just for you to know, if you go to the the cuet.samarth.ac.in website, you can get the syllabus. And this is the syllabus where all the chapters that you are covering in 12th standard, most of them are being covered. So we have already, our idea is to do a super preparation series of the CUET, where we'll be covering all the formulas required in one video, and then we'll be doing a lot of questions, numericals based upon that chapter in a second video. So we have already done all the formulas for solid state, electrochemistry, chemical kinetics, and we have already started the put many questions on P block, D and F block, etc. So all these, I'll be giving the link of all these videos that we have done before in the description box below. You can take a look at them. And today, what we're going to do is something that we have not done before, which is the chapter solution. So we'll be talking about all the different formulas, important formulas in this part, and also just start with some questions, mainly not some very much in detail, but some questions as well. So let's go to that. We are going to start now. We are going to talk about the most important formula and the sample questions from the chapter 2, which is solutions. So let's start. First of all, these are the main important formulas. Let's take a look at them one by one. So mass percentage of any solute can be given by the formula mass of. So if you're looking for a component A, we have to take the mass of that component A in the solution and the total mass of the solution and multiply it by 100. Since there is a percentage terminology over here, that is why we are multiplying it by 100. And what happens when it is volume? Instead of the mass, you'll replace it by the volume. So if you want for a component A, you have to take the volume of the component A in the solution. So there will be more than one components in the solution. So you'll take up a volume of the one that you want to calculate the volume percentage, divide it by the total volume and multiply it by 100. Now, mole fraction is a different concept. So mole fraction is showing the fraction of how much the particular component is present in the total system. So number of moles of the component A by total number of moles consists of the mole fraction. And since this is a fraction, the highest value the mole fraction can have is number 1. So it can have maximum value of 1, not more than that. So that is the important point that you have to remember in the mole fraction concept, that the maximum value that you can have is 1. So if you have two components and the mole fraction of 1 is 0.2, then the second one would be obviously 1 minus 0.2, because there are only two components and the total mole fraction always remains 1. So mole fraction can be calculated in that way. Next is parts per million. So again, similar to what is done previously, the number of parts of the particular component that you have to calculate divided by the total number of all parts. And then you're multiplying it, this one by 10 raised to 6. Why? When you have percentage, it is 10 square or 100, and it is parts per million. Million is equal to 10 raised to 6. That's why we are looking at it in this format, where number of parts of the particular component by total into 10 to the power 6. Now, most important concepts are these three, where molarity is the number of moles of the solute by volume of the solution in liters. Very important. If the volume of the solution is given in ml, you will be multiplying the numerator by 1000 or 10 to the power 3. So you will have to multiply it by 10 to the power 3. Sorry for my writing over here. So it's been a while that I have written something like this. Forgive me for that, but I hope I'm clear the concept. So molarity, the total number of moles of the particular solute divided by the volume of solution in liters. And remember, if it is given in milliliters, multiply the numerator by 10 to the power 3. Then comes molality. Molality is again something similar, but here we are taking care of the mass, and here we are not considering the mass of the solution in the denominator, but we are considering solvent. So number of moles of the solute divided by mass of solvent in kilograms. Again, if the mass of the solvent is given in grams, you will be multiplying the numerator by 10 to the power 3 to make it equal. Normality is similar to molarity, except in the numerator, instead of number of moles, we will be using number of gram equivalents of the solute. Again, if the volume is given in ml, you have to multiply the numerator by 10 to the power 3. These are the basic formula of this chapter. Now coming to the little more complicated portion, which is first Raoults law. So Raoults law states that the partial pressure of a particular component. So if you are talking about component 1 in here, so if you are talking about component 1, the partial pressure of the component 1 can be written as the product of mole fraction of 1 multiplied by the fraction of the partial pressure of this in the pure state. That is the vapor pressure in the pure state of the component. So P1 partial pressure inside the solution will be P10 into X1, where P10 is the partial pressure in the, vapor pressure in the pure state, and X1 is the mole fraction. Similarly, if for a component 2, the same formula applies, where P20 into X2 will be happening. Now, according to Dalton's law, another law, it shows that the total pressure of a solution will be the sum of partial pressure of each of the components. So, if P total with two different components are there, it will be P1 plus P2. So, we know that P1 is equal to P10 X1 and P2 equal to P20 X2. And also, we know that X2 will be equal to 1 minus X1, or X1 is equal to 1 minus X2. So if we are using all these formula, we will get two different equations. One is the mole fraction of component 2 can be expressed only in terms of the partial pressure and vapor pressure of the component 1. So this is one interrelation. So this we have to remember. So according to Dalton's law, the total pressure is the sum of partial pressures of each of the component. And using the Raoults law, combining Raoults law and Dalton's law, you can get the mole fraction of component 2 only in terms of the partial and vapor pressure of component 1. Hope this is clear. Next important concept in the case of solutions, the chapter solution, is elevation in boiling point. So when you are in a solution, if you are adding a solute into a particular solvent or a solute, the boiling point, the initial boiling point of that solvent will be decreased once the solution is happening. Sorry, increased. So the boiling point will be increasing once you're adding a solute, and this is known as elevation in boiling point. So the elevation in boiling point, that value can be written as delta TB. So delta stands for some difference. So TB is the change after increased pressure, increased boiling point, and TB0 is the initial for the pure solvent, whatever was the boiling point. So that can be expressed by this KB, which is the constant boiling point elevation constant, and 1000 W2, M2 and W1, where M2 is the molar mass of the solute, W1 is the mass of the solvent in this one, and or the second component in this one, and W2 is the mass of the solute. So these are the important things that you have to remember. So just like how we have elevation in boiling point, once again elevation in boiling point, there is a molar elevation constant. Then W2 is the mass of the solvent, W2 is the mass of the solute, W1 is the mass of the solvent, M2 is the molar mass of the solute. So with this you can find the elevation in boiling point. Similar way, this is this is depression in freezing point. So this is the depression in freezing point. That is why we have given F. So depression in freezing point can be written as delta TF, and it is very similar. Instead of a molar elevation constant, here you have a depression constant. The rest of the things remain the same. And you should be very careful about the units of these things. Everything should be in similar units, and otherwise this will not make sense. So you should have these things in grams so that this 1000 makes the sense. So that's how you have to do this. Okay, so elevation in boiling point and depression in freezing point. After that, another important concept is osmotic pressure. So osmotic pressure is written in pi, and pi is equal to CRT. So C is the concentration, T is the temperature, and R is the gas constant. So again, gas constant has different values according to the units that you're using. So whatever question you are seeing, according to your question, and what is asked in the question, you have to change the unit and the values of the gas constant. Now from this pi value, you can calculate the molar mass of the solute. That is another important question repeatedly asked in all the examination. So molar mass of the solute M2 is equal to W2 RT by pi into V, where W2 is the mass of the solute added into this particular solution, and then you have pi is the osmotic pressure, V is the volume of the solution, R and T we have already discussed. So this is how molar we can calculate the molar mass from osmotic pressure. Next, when there is no complete association or dissociation in that case, then there will be something called Van Hoff factor. So this that will be showing that the exact molar mass that we expect might not be there. So there will be a normal molar mass and an abnormal molar mass. In these cases, we'll get a factor I. So this is same for everything, even in observed colligative property A divided by calculated colligative property, total number of particles before or after association, and total number of moles of particles, same thing. So this one should be taken into account, I value. So once you're including the I value during association or dissociation, we will be adding that factor into all the equations that we have learned before, like elevation in the boiling point, depression in freezing point, osmotic pressure, and so on. So how did you get this N2 by V? We know that this concentration can be written as mole by volume. So number of moles divided by volume, that can be given as the C value. So that's why you have I into N2 RT by V. Now, these are the different formula that you have to remember. We have discussed all the important formula. Now, let's take a look at two very simple questions in this part. One, calculate the molarity of each, like 20 ml of 0.5 molar H2SO4, which is diluted to 300 ml. So now, first of all, you have a volume of undiluted H2SO4. So what is asked? Before dilution, it was 0.5 molar. So now it is diluted to 300 ml. So what is the change in the molarity? That is what you have to calculate. So the total volume before diluting is 20 ml. And that case, the molarity is 0.5 molar. Now, after dilution, it is diluted to 300 ml. So that is V2. And now we have to find M2. So this formula we have not discussed before. This formula is M1 V1 is equal to M2 V2. Whenever we are doing, this is the dilution. For dilution, we are using this equation always. So M1 V1 will be always equal to M2 V2. So from this, we can calculate M2 as 20 into 0.5 by 300, which is 0.033 molar. So this is one important question which can be asked. The dilution formula is a commonly asked question. So please remember this, note this down along with the other formula, and will be helping you for the exam. Now let's take a look at another simple question, which is based on osmotic pressure. So here the question is asked, osmotic pressure is to be calculated in pascals. This is very important. Whenever the question specifically asks for some sort of unit, you have to always calculate it in that unit only. So they have given the mass of the solute added, molar mass of the solute is given, what is the volume, that is also volume of water is also given, then temperature is also given, everything is given to you. This is a very direct question what you have to calculate. So here volume is equal to 450 ml, so we have to convert it into liter, dividing by 1000 we get 0.45 liter. Then temperature we are converting into Kelvin, which is 310 Kelvin. And R should be given here. This value 8.314 should be used, because in that the pressure unit is not in ATM, but it is in kilopascal. So if it was asked in ATM or atmosphere, you have to use the constant of 0.083. So that constant will be used. So according to what is asked, you will be changing the constant. Now, if you are applying the formula, you'll have pi value, which is CRT. You have N. N is given as, N can be calculated. N is the given mass by total mass. So N is equal to 1 divided by 185 molar mass. Given mass by molar mass give you the number of mole. So once you have that, you are directly substituting, and then you will get the value of pi or osmotic pressure. So the value is 30.96 pascal. So these are just sample questions. So in the next video, we are going to cover entire thing. So like I told in the beginning, we have covered similar portions of solid state, electrochemistry, gaseous state, D and F block, and all these things. I'll give the link to all those videos in the description box below. Watch each of them, write all the formulas down. So the super preparation series for CUET 2023 chemistry will be continuing again. So thank you all for watching. Please continue to watch our videos. Thank you. Till the time we see again, take care, study well. Let's hope all of you qualify the exam this time. Thank you.